Okay, so now we are moving to properties of exponents in scientific notation. So the property of exponents, basically, if you have a number of base a raised to power x and you multiply it by a number with the same base raised to power y, you add the exponents, the values of the exponents. Now if you have a number with a base a, whatever that number is, and you divide by a to the x divided by a to the y, you still have the same base, but you subtract the value of this exponent from that exponent. If there's no exponent, a is the same as a to the first power. We just don't include it because it's just a by itself, so it's kind of redundant. Also, any number to the 0 power is 1. So 10 to the 0 power is 1. 100 to the 0 power is 1. The only one that isn't that is this one. 0 to the 0 power is not 1. But every other case, or infinity to the 0 power. But the other one is the exponent. We have exponent and exponent. So you have some base a raised to the x power, and then you raise that to the y power. So, if I had 2 squared to the 3rd power, well, 2 squared is 2 times 2. And when you have numbers that are multiplied together, so that's another thing I guess I need to show you. So you can take, if this is a multiplication, you can raise each one of these to the power in the outside of the parentheses. So you get 2 cubed from this first 2, and you get 2 cubed for the second one. And so when you multiply these two together using the multiplication rule, you add the exponents. So you get 2 to the 6th power. Well, if you look here, it's not these two added together. 2 plus 3 is not 6. It's 2 times 3. So the rule here is that this would be a to the x times y. So you multiply the exponents together in this case when you have a parentheses and an exponent inside and an exponent outside. The other case, what I was saying was if you have a product of 2 numbers raised to some power, it's the same as each one of the numbers raised to the same power. So those are the rules of exponents. And so let's look at the homework problems. So we have started problem 7. So it's 5 to the 4th power. It says evaluate each exponential expression. So if you have a calculator that has exponential on it, you could do it that way. But what this is 5 times 5 times 5 times 5. So even if we didn't have the exponential function in our calculator, we could rewrite it as what it really is. It's 5 times itself 5 times. So if you do that, you'll get 625. Okay, number 10. Negative 5 to the 4th power. So that's negative 5 times negative 5 times negative 5 times negative 5. And for you guys from the first semester, we know that if you have a product or quotient or combination of products and quotients, that the final sign is positive if the number of negative signs is even. So I have 1, 2, 3, 4. 4 is even, therefore the final answer is positive. And then I just multiply the numbers together, which I've already done up here. So it's positive 625. Now, it would be different if it was negative 5 to the 3rd power, because that would be negative 5 times negative 5 times negative 5. And they're an odd number, so the answer is negative. And when you multiply 5 times 5 times 5, you get 125. So the rule is if you have a negative number inside a parentheses, and if the exponent is even, then the answer should be positive. And if the exponent is odd, it should be negative. Because if we expand it out, we see that. Okay, 13 is negative, a negative 3 to the 4th power. So there's a couple of ways you can think about this. You know, this is going to be negative, and I'm going to put these square brackets. You have negative 3 times negative 3 times negative 3 times negative 3, close the bracket. So negative 3 to the 4th power is negative 3 times negative 3 times negative 3 times negative 3. I've got an even number of negatives, so the number in the bracket is going to be positive, and I'm going to have 3 times 3 times 3 times 3, which is 3 times 3 is 9, times 3 is 27, times 3 is 81, so it's going to be positive 81. But then I have this negative sign out in front, which means that I change the sign of whatever's in the parentheses. So I get negative 81. Now this contrasts to if you had negative 3 to the 4th power. If you don't have a parentheses, you don't know whether this is negative 3 to the 4th or the negative of 3 to the 4th. And so if you don't have parentheses, you have to assume that this only applies, this 4th power only applies to the 3's. So I take 3 to the 4th power, which is this, which is going to be 81. And then I get inside is 81, so it's going to be negative 81. Whereas if I had negative 3 to the 4th, then that's this part here. It's going to be positive 81. So you'll notice that if you look at problems 9, 10, 13, and 14, you see there are parentheses around the negative number. That means that's the number, negative 2, negative 5, negative 3, negative 5. You're raising that. Whereas problem 11, problem 12, the negative sign is not in parentheses with the 2, so it's 2 to the 3rd and then change the sign. Okay, 16. So we got 4 to the negative 1 power. So this, when you have a negative exponent, and I'm going to rewrite this as a rational number by putting 1 in the denominator. When you evaluate things with negative exponents, you actually never do it you always have to convert it to a positive exponent. Well, the way you can convert something from a negative exponent to a positive exponent is to move it from the numerator to the denominator or the denominator to the numerator. So in this case, by moving the 4 to the denominator, which just leaves 1 in the numerator, you change the sign. And therefore, then you evaluate this with the positive exponent. 4 to the 1st power is 4, so the answer is 1/4. Now if you had 1 over 4 to the negative 1 power, what I would do is I would move that to the numerator, make it positive, and then replace this with 1. So it's just the exact opposite of that. And the answer would be 4. So notice I have to have this intermediate step. If I just showed this and put a number, I obviously either am very smart or I don't know what I'm doing. So I always want to make this a positive exponent. So here's another example. 3 to the minus 1 divided by 6 to the minus 1 power. So I can't evaluate that. I have to rewrite this so that this becomes a positive exponent. Well, the only way I can make this positive is to move it from the numerator to the denominator and change the sign. Likewise, this number, I can make it positive by moving it from the denominator to the numerator. And then 6 to the first power is 6, 3 to the first power is 3, and then I can simplify that, and the answer is 2. But notice I don't evaluate the exponent until I make it a positive number. So 19 is an example of that. So we've got 2 divided by 4, negative 4 to the negative 3 power. Okay, so this is negative exponent, not something I like. So I'm going to take this and I'm going to move it from the numerator denominator, the bottom, to the top, make that positive. I have that. Now any number divided by 1 is just that number. And then finally, negative 4 cubed is negative 4 times negative 4 times negative 4. And then you do the multiplication out. Notice I'm going to have a negative final answer because I have 1, 2, 3. I have an odd number of negatives. So now my answer is negative. And then all I have to do is multiply all the numbers together. 2 times 4 times 4 times 4. And I get 128. So the answer is negative 128. Okay, let's do one more. 22. So I have 1/2 to the negative 3 power. So again, this is a negative exponent. So how would I do that? How would I switch that? Well, there's a couple of ways you can think of it. You could rewrite this as 1 to the negative 3 power divided by 2 to the negative 3 power. So that's one of those rules. I guess I didn't show that. If you have a over b to the x, it's the same as a to the x over b to the x. So it's similar to the product rule. So if you have a quotient raised to an exponent, it's the individual terms of the quotient individually raised to the exponent. So what I've done here is I've had 1, which is the numerator. I've raised that to the negative 3rd power. Likewise here with 2. Now that they're separated out, I can take this term and make it positive, the exponent positive. So moving it from the numerator to the denominator makes the exponent change sign. Likewise here, I can change the sign like that. I can then evaluate those. This is 2 times 2 equals, that's 2 times 2 times 2 divided by 1 times 1 times 1. And so the answer is 8. Now the other way you could do it is you could actually, if you have a negative exponent on a rational number, you can just flip the 2. So what that's basically saying is if I had a over b raised to the negative x power, that's the same as switching the numerator and the denominator and raising that to the positive x power. So it's basically the same thing, except it would leave out one step. I just have to, instead of 1/2 to the negative 3 power, it'd be the reciprocal. 2 goes to the numerator, 1 goes to the denominator, raised to the 3rd power. Well, 2 divided by 1 is 2. 2 cubed is 2 times 2 times 2, which is 8. So you get the same answer. Either way, it doesn't matter.